Hello, everybody. We're continuing section 2.2, organizing quantitative data. In the previous part, we talked about organizing discrete data in tables and creating histograms using discrete data. In this part, we will talk about organizing continuous data in tables and creating histograms for continuous data. We know that classes are categories into which data are grouped. When a data set consists of a large number of different discrete data values, or when a data set consists of continuous data, we must create classes by using intervals of numbers. The following data represents the number of persons aged between 25 to 64 who are currently work disabled. And notice that we have our class in intervals because we are looking at huge number of population. In this case, those numbers are in thousands. So it is impossible for us to make our classes individual numbers like 25, 26, and etc. The lower class limit of a class is the smallest value within the class, while the upper class limit of the class is the largest value within the class. The lower limit of the first class is 25, and the upper limit of the first class is 34. The lower limit of the second class is 35. The upper limit of the second class is 44. The class width is the difference between two consecutive lower class limits. So in this case, the class width is going to be 35 minus 25, which is equal to 10. Let's look at this example. We have discrete data in this case, but the variety in this data makes it impossible to create classes from individual numbers because 45 classes will be too much and it's not going to show us any trends in our data. So the solution is to create interval classes as follows. Notice that the smallest data value in our raw data was 672 and the largest value is 738. We create the classes so that the lower class limit of the first class is a slightly smaller number or equal to the smallest value in our raw data. Preferably, it is going to be a convenient number that is less than the smallest data value in our raw data. The class width in this case is 10. As you can notice, 680 minus 670 was 10, so we chosen 10 as our class width, and we build our classes as follows. To create the classes, we start with the number 670. That is the lower limit of the first class, and then create the lower limit of the second class, which is the lower limit of the first class plus the class width, which is 10. So the answer is going to be 680. We take one number less than that and make it the upper limit of the first class. So it's going to be 679. And then we continue adding class width to the upper limit and lower limit until we create the entire classes. Notice that the largest number here was 739. It's slightly bigger than the largest data in our raw data, which is good. So when you see a number that is slightly larger than our largest data value, we stop. After we created our interval classes, we put them in our table. We start counting the frequencies of the numbers in the first interval, second interval, etc., including the lower limit and the upper limit numbers. To create the relative frequency column, we divide each frequency by the sum of all frequencies. In the previous example, the choices of lowercase limit of the first class and the class width were rather arbitrary. There's not one correct frequency distribution for a particular set of data. However, some frequency distributions can better illustrate patterns within the data than others. So constructing frequency distribution is somewhat of an art form. We use a distribution that seems to provide the best overall summary of the data. To show you what I'm talking about, let's look at this example. In this example, you notice that the class width is 5, but there is a slight problem here. I have a big gap in these numbers. They don't have any frequencies, so a class of 5 in this case for this set of data is not convenient. To determine the lowercase limit of the first class and the class width, we have some guidelines that we should follow. To choose the lower class limit of the first class, we choose the smallest observation in our data set, or we choose a convenient number that's slightly smaller than the smallest value in our observation. To decide the class width, first we need to decide on the number of the classes. Generally, a good number of classes will be between 5 and 20 classes. The smaller the data set, the fewer classes you should have. And then to determine the width of the class, we use the following formula. We subtract the smallest data value from the largest data value, and we call that the range of our data, and then divide the range of our data by the number of classes that we just chose. After you calculate that, remember to round this value up to a convenient number. In part 1, we discussed constructing histograms for discrete data. And in this part, we're going to discuss constructing histograms of continuous data. So essentially, constructing histograms for continuous data is the same process as constructing histograms of discrete data. Let's look at this histogram that represents our previous example using class width of 10. Notice here that the beginning of the rectangle is the lower limit of the first class. The end of the rectangle is the lower limit of the next class. We continue creating our histogram in this manner, and the height of each rectangle represents the frequency of each class. In the same manner, we can construct relative frequency histograms of continuous data. Everything is similar to the previous histogram except for the y-axis, which represents the relative frequency or the percent. So the height of each rectangle represents the relative frequency, not the frequency. Here is another histogram for the same set of data, but the class width here is 5. A histogram that represents the same set of data, but the class width is 5. Notice here that we have lots of ups and downs. This does not show a clear trend in our data. This just shows us that a class width of 5 is not convenient.